Well, you guys wanted to see more of this truck, so let's see more of this truck. It is running. Got it running in the last video, and we've got a ton of stuff going on with it, so I'm just going to break it down into sections and kind of just chip them away one at a time. And first thing we're going to tackle is this service battery charging system. Got a battery light on, message. It does actually set code in the ECM. Check engine light's not on yet because I just started it. If I shut it off, crank it a couple more times, it'll come on. But on the scan tool here, we've got a P0621 that is setting. And let me start this. And we'll go over to all data, read this code description, and figure out why this thing isn't charging. As you can see on the scan tool though, we're charging at 13.65 volts. That is a default setting the alternator will do. So let's get into this, figure out what's going on with this L terminal circuit, and what else is going on with this truck. Alright, so we've got all data pulled up here, and I already got the code pulled up, this P0621 generator L terminal circuit. And basically this fault information chart kind of gives you an idea of things that could be going on with this. So a P0621 could be the L terminal short to ground, open or high resistance, or even a short to voltage. So this one code covers pretty much anything that can happen with this circuit. This circuit system description kind of explains what the ECM's doing, what it's looking for, how it controls this alternator. So I'll let you pause the video right here and read this if you want to. But it basically just tells us that the ECM is controlling the alternator with a pulse width duty cycle, basically. And yeah, so if we pull up our starting and charging schematics here, we are a LC8, I believe, or L96. Either way, this should be our diagram that we're needing, and we are looking specifically at this generator L terminal, so pin 1 on the generator here. We don't have a snowplow relay that I know of, so that's kind of strange. There might be a snowplow relay on the fuse box, I don't know. But either way, the engine control module is basically showing a switch going through this relay and to the generator. So we're just going to start out at the alternator, get probed into this wire, and see if we're getting some kind of signal there or not. Alright, so I got the key on. We'll go into the scan tool here and just look at some live data. So read data stream. This alternator stuff is going to be on GM under the electrical and immobilizer data. So we'll go down here, and we got our F terminal and L terminal stuff there. We're going to select those. So key is on right now. We got generator F terminal signal 0%. L terminal command is 0%. So our operation and description says that while the engine is off, we should see low voltage coming out of the L terminal. And I've got back probed here, and on the meter, yep, no voltage. So let's crank the truck and see if we get any voltage there or not. Okay. So our F terminal is saying 28%, our L terminal is saying 73%. Is what his command is. So right here we should see 73% of 12 volts basically. And what do we have? 0.2 volts. So yeah, we've got an issue. Let's see if we've got a duty cycle. So let me get this down here where I can see it. So right now we're on hertz. Let's change. Oh, percent right there. 86%, 85%, 87%. That is actually matching kind of what the scan data says. So this is reading a duty cycle, but the voltage is not there. Yeah, we got 0.25 volts. So very low voltage. That's the problem with meters, regular meters. Yeah, it tells you some of the story and it's seeing something, but it's no replacement for a scope. So let's get a scope out and let's actually see what this signal looks like. Now, we're gonna have to use the snap-on because I forgot my Pico at my shop. So, but that's okay. Snap-on's got it here. And I know y'all are gonna not be able to see this because of the glare, and the screen recorder slows this thing down a lot. So I'm gonna screenshot this and y'all can see that we do have a little bit of a square wave, but we don't have any voltage. Like it's not coming up like at all. Like this was actually really right. It said we had a voltage of 1/4 of a volt. Well, we've got a 1/4 of a volt live voltage on the scope here, and this was reading a duty cycle, 80%, whatever. It was basically matching what the command was, but it's only reading on that 1/4 volt. So this thing's actually good enough to see that low of a duty cycle on that low of a voltage scale. So I'm kind of impressed by that. And the scope proved it. So yeah, we've got a duty cycle there. It's just not being brought up. So is it an ECM problem or is it a alternator problem? We don't know yet. Let's do a little more digging. So I went back and looked at my diagram. The ECM is actually supposed to be sending out a voltage, okay? And the alternator is supposed to see that voltage to command itself on and whatnot. So if we're pulled low, that makes me think the issue is either in the wiring being pulling that low, or in the alternator is pulling it low, and is not able to come up off of basically ground, essentially. So I went back and looked at the trouble tree, and basically it wants us to check our battery terminal here for power. If that lights up with a test light, it's good. And then they wanted us to basically unplug the alternator and check for voltage with the engine running on the L terminal. And basically that's what I've got now. I got this unplugged, and on the scope you can see we've got a 5 volt and then a pull down. I'm taking a screenshot of this here so you can see that. And on our trouble tree, it says unplug that with the engine running, test for 3 to 5.5 volts on the control terminal and ground. If greater than 5.5, you got an issue. If less than 3, you've got an issue. If between 3 and 5.5, test or replace the generator. So we've got a bad alternator. All right, now that we got that charging system situated, we'll get an alternator coming for this thing. We're going to tackle these ABS wheel speed sensor codes. We got one for left rear and right rear, both rears. And we see they both have a symptom byte of 05. So C0045-05 and C0050-05. So on all data, we've got basically the wheel speed sensor codes pulled up here, and we can see our 05 designation is like so, 45 here. Left rear wheel speed sensor circuit, high voltage or open. So it's basically thinks either the wire is broken somewhere between the EBCM, the sensor, and then back to the EBCM. Let's scroll on down here and we'll get the wiring diagram pulled up for this. So wheel speed signals, zoom in here. So I don't know why they make that big loop there, but whatever. So we got both rears. They don't have any connectors other than the connector on the actual speed sensor itself. And you can see that we've got a 12 volt supply feeding out, goes into the sensor, out of the sensor, back to the EBCM, and we can see that it has this little arrow spot. That is where the module is taking its sampling from. And then we've got that resistor and then a ground on the other side of that resistor. Basically, the module says we've got an open circuit, so that's actually going to be pretty easy for us to test with a scope and a small light bulb. All right, so I've got my connections set up down here, and the wiring diagram shows that our positive 12 volts is a gray with black stripe. Y'all are not going to be able to really pick it up there, but that is my yellow wire here, and then the ground side going back to the module that it reads is my black one. And I've just got them plugged up into the various. I've got a trigger set up to hopefully catch it if it comes on. Some of these times, or some of these modules, when they do this wake up circuit check, if they're not happy about the circuit, they'll turn back off really fast. So I've got a light bulb in here. This is my 50 milliamp test lamp that y'all know I love. I'm hoping it's going to be enough of a load to where the EBCM sees it and it stays powered up, but not too much of a load where it detects a short to ground or a short to power or something weird and turns it right back off. But hopefully the scope will catch it anyway. So basically what we've got the key off, modules are asleep, and we're basically going to cycle the key on. The EBCM is going to do a circuit check of all the sensors by basically pulsing this 12 volts, and it's looking for that 12 volts to return on that ground or low reference side that it's sampling. And that way it's going to know that it's got a good circuit. So I'm going to set you guys down here, let y'all watch the light bulb and the scope, and I'm going to go turn the key on. Alright, so I've got the key, I'm sticking it in the cylinder and turning on. Did we get anything? Yes, we still have a light. Yep, awesome. And you see we did get some return voltage. Let's make that go away and we'll see what that really is looking like. Let's turn this none. Exit. So there we go. We've got our basically our battery voltage returning to the module. The module right now is probably happy. It might clear that code. It might reset for a different fault. So let's go scan it and see what it says. I know it's somewhat happy though because it still has the light bulb on. So it didn't turn the circuit back off. So on the scan tool here, let's get back over here. And let's go into the module. Read fault code. Like I said, I'm hoping we either get that code go away. Yep, history. There we go. So that code is now history. So that is confirmed. One bad wheel speed sensor. We'll duplicate this for the other one, but chances are it's a bad one. But we're gonna double check. We're gonna confirm. I got the same test done on the opposite side, and you can see now our, well, let's see, history. Let's see, where's my other one go? Ah, there we go. C050 history. So our right side is now happy according to the EBCM. We've got our light on. Our scope is showing almost battery voltage there. So I want to do one more little test. I want to show you guys what a circuit check looks like on some other cars where it might turn that on for a second and then turn it right back off. And the way I'm going to do that is basically I'm just going to unplug my bulb out of here. You can see my voltage drop down pretty fast after that. Module's still going to sleep, but let's change our time base to like 50 milliseconds. We're going to put a trigger back on there. We're going to leave it on manual in case it tries to turn back off. And now we're going to go turn the key back on and see if we get a voltage come up and then turn back off. So keys on. A lot of cars like Hyundai, Kias will do this test relatively fast. So you see it is on. It stayed on for actually kind of a lot longer than I thought. Let's go back to record, but see on record we're back down. Let's turn the trigger off. None, exit. Well, it's still got power there. So this one's not actually going to turn it on and turn it back off. But either ways, if you don't have a test light or something to load it, some of these cars will just turn it on and then turn it back off. Like I said, Hyundai Kia is pretty known for turning it on and back off. I think I've checked some of them where it was a 2 millisecond circuit test. I probably got some screenshots of those waveforms somewhere I could dig out maybe. I'll look and see. But yeah, some of them are really, really fast, turn on, turn back off, just circuit test. So there we go, confirmed 2 bad rear wheel speed sensors. What do you guys think is wrong with this truck? What do you think was the cause of this truck? I know some of you have been commenting on battery hookup backwards. Some of you saying maybe a welder. Well, this truck doesn't look like it's had any welding done to it. It's all stock. Everything looks good. Has been off-road on some dirt roads a pretty good bit, but yeah, no welding, no exhaust damage, nothing like that. I've not seen any signs of a battery hookup backwards. Usually if you got a battery hookup backwards, you'll see some signs on the cables, like where the cable touched the post or something. It'll be black, like you'll have some noticing like arc damage. Neither one of these cables look like they've been damaged at all. This is a new battery, but no signs on the cables of them being hooked up backwards, like no damage to them. So yeah, even if it was a battery hooked up backwards, you could never explain that to have killed 2 rear wheel speed sensors. Or maybe an alternator, wheel speed sensors? No, come on now. Nope, we are going with pretty much confirmed lightning strike truck. Just too much carnage, kind of all over the place, different issues with different things. So yeah, going with lightning strike. So all right, what's next? Let's go with these limb bus codes.